One person on the meeting code. It was always Okay, let's make a start. Welcome to NVO3. The blue sheets are just going around either side of the group, so please sign that when it reaches you. Here's the note well. I'm sure you have taken many hours to read, so please do consider that. Okay, so blue sheets, we have a JavaScribe already. Thank you. So the agenda. So this was posted on the list last week. Any comments on the agenda? We have an hour and a half, so we have a couple of drafts that are or a couple of slots that are, if time permits, we get to those. We also had a last-minute change in that we allocated a little bit more time to the OEM design team update, the overlay OEM design team update. Okay, so working group personnel. So Sam has taken over as co-chair from Benson, so please welcome Sam as my new co-chair. And Benson, who's not in the room I think at the moment, decides to thank Benson for his many years of really good contribution and support for the working group. And we're looking for volunteers for working group secretary now, because of course Sam used to be our working group secretary. So if you are interested in that role, please come up afterwards and have a talk with us, or drop us an email. Milestones. So as usual, we have failed to update our milestones, but we have progressed at least one of them anyway. So we will post, definitely this time, some updated milestones after this IETF. Just wanted to have a quick mention of OEM in the working group, because this has been a fairly significant activity over the last few months. There's a routing area overlay OEM design team, and there's a report back from that on the agenda for this meeting. We also have OEM work and a design team within the working group itself, which has been developing OEM requirements and framework really pertinent to the NVO3 data plane encapsulations, looking at solutions including, and these are drafts that have been presented in the working group to some degree in the past, things such as transcending traceroute, PMTUD, path detection, and so on. There's also been some discussion of a Yang model for OEM in that design team, but we're going to have more discussion of OEM later on in this session. So, document status. So the working group has 2 RFCs that have been around for a long time, 7364 and 7365, but we've had no new RFCs since the last IETF, and we have no documents in the RFC editor's queue at the moment. We still have of course, some requirements documents, including data plane requirements and some control plane requirements documents and security requirements. The basic data plane and control plane requirements, we said we would progress those requirements in parallel with the applicable solutions. So we won't be moving forward with those until we have some solutions ready to last call. However, the security requirements document, we did have a working group last call, but really didn't have a lot of feedback on that draft. I think the original intent was to take some of the text potentially from that draft and incorporate it into the security considerations of solutions documents, or another alternative could be we publish that document in parallel with solutions, and solutions refer to those requirements or address those requirements. So we are still looking for a way to progress and forward and at least get some more review and feedback on this document. So, so the architecture draft, that's currently with Leah, that we went through last call, and we've requested publication of that. We have a multicast framework document that passed working group last call as well, and that's awaiting the Shepherd's write-up. We also have a use cases document. We're interested to know as chairs what the working group thinks on how this draft at the moment helps define solutions before progressing that. We've had a number of requests for working group last call for that document, but it hasn't been worked on in the group for quite some time now. So if anybody has any comments on whether they think this document, the interest level of this document, and whether it helps define the solutions in the working group, or if it's too high level, for example, please send those to list or speak now. Okay, if I just get an indication, maybe a hum, if you've read this document, or put your hand up if you've read this document. We have one person. Okay. Okay, please do take time to have a look at that document and provide any feedback. Hello.
Sure, Leah Atlas. So use case documents can be really helpful at the beginning of a working group, but the thing to think about when looking towards publication as an RFC is how useful is this really going to be in 2 or 3 years. And if there is not strong, enthusiastic belief from the working group and consensus that it's really going to be helpful, it's possible the document has outlived. I'm sure that you've heard a fairly consistent pushback against use case documents as simply progressing to document. They can be very useful to help form the discussion. If it's not going to be helpful in 2 or 3 years, and there's not enthusiastic understanding of how it could be, then that's an issue. One thing I have and am suggesting is to think about shaping use cases into sort of applicability. Here's the use case, here's the technology that's been defined and how you can use it, instead of, which helps give a little bit more guidance, I suppose, and suggestions for operators to understand how the technology might be useful.
Lucy Yang from Huawei. Yeah, I'm the use case co-author. I think this use case, yeah, I agree. We've been writing this draft a long time ago, and we are required the work group to process this work. However, this working group in 4 years doing very, very little things. I don't think it's fair saying now we are restructure this piece of work doing some other things. That's not really fair for the co-authors because, you know, a lot of things, you know, we are very, you know, want the pushing this work, but working group is doing less work than. So for the other applicability draft, if you support for other purpose, having another draft, that's fine. This draft clearly defined this the inter-data center use case and also this DCI use case, which is the popular use case.
Eric Nordmark, yeah, briefly looked at the document. I mean, it's not very long, but I don't know if it adds that much because the things that are there, like these use cases, as well as, you know, talking about L2 and L3 virtual networks, we have that in the other documents, right? So it's sort of, it might have served its purpose already. Okay. If we can't get reviewers, and if it, yeah, you guys have to figure it out.
Okay. Okay, we have some other work that's been moving around in the working group. There's a control plane mapping distribution draft unbar, and the authors have requested adoption of this as a working group draft. So we will be post a call on the list shortly, and we're looking for some help to develop an NVO3 Yang model or Yang models. We're also looking, I know the IEEE are looking for help with some Yang modeling for VDP. So if any folks are interested in that, I think probably talk to Pat. Any other interest in developing Yang models in the group? So I think if you are interested, please come and talk to us after the meeting. Okay. So Pat, I think, who's doing this one? Okay. Thanks. Oops.
Okay, so we're doing the communications protocol through the split NVE. We're doing that by extending a protocol we have in 802.1q called VDP, which was for kind of a similar thing, and so it's pretty easy to extend. We've got a draft, and our editor is Yi Zhao. You want to stand up? That's it. We've got a draft that's pretty far along. I think, well, it's pretty far along in being drafted. It hasn't had any balloting yet, but I think given that this is drafts being done for this group, really, I will be asking in 802 next week to liaise that draft to this group so that this group can comment on it. And we have a process for doing that because our drafts have to be behind a password, but generally what's done is the IETF working group chair is given the password for accessing that draft, and then anybody can ask them to hand it out. The thing that's not in the draft is any kind of Yang model. We don't, VDP was done in the days of MIBs. And we could extend the existing MIB. It's not a very long MIB. But it seems like a Yang model would be much more useful to this group. And we're going to need help from a volunteer to help draft the Yang for that if we're going to have Yang. Otherwise, we'll probably end up extending the MIB, and somebody will later have to come and translate that into Yang. So,
quick clarification question. So the Yang model will be within the IETF, or it will be in the IEEE?
I think it'd be preferable to put it in the IEEE draft, but possibly it could be done here. I think if we have somebody to draft it, we could figure out where to have it go on. I think in general, the preference is to keep the Yang models with the standards. But this is kind of a special case because we're doing this protocol extension for this group. So, I guess we could figure that out, but we need somebody to write the Yang. So I don't know if nobody wants to volunteer right now, we can. Sure, you can talk to the chairs or to me later and see about doing that. I think it can be done, I think, without coming to meetings if that's a concern. I think we're doing a lot of the work on this over conference calls anyway. Okay, so that's basically it.
Okay. Thank you.
Hi, my name's Tom Herbert, and I'm going to give a little bit of an update on identifier locator addressing. I think I might have presented a while back, so the point of this is give a little bit of an update where we are kind of in implementation and deployment, and also we're kind of seeking some feedback on where this belongs in IETF, so we'll get to that in a minute. So ILA is a type of identifier locator address split, and similar to ILNP, we split the address right down the middle, an IPv6 address. The locator is the upper 64 bits. This is a physically routable sort of address on the internet when it's translated. Low order 64 bits are a unique identifier, so the identifier is similar to the address of a virtual node. Locator is location. Next slide. Flow example. So the idea is an application will look up, say, an address in DNS, gets the result, sends a packet. This is routable to what we're calling an ILA router, which actually has the mapping database of the virtual address to the physical address. So it'll do the translation, send the packet on its way to the actual end destination. And the translation in this case is overwriting the upper 64 bits of the destination address with the locator. So there is one optimization here we can make, which is the ILA router can actually send back a type of redirect to the originating host. And if the host does ILA, it can subsequently send directly to the destination and kind of bypass the triangular routing. Next slide. So we kind of identified several use cases for ILA. The one that we initially targeted, particularly at Facebook, was what we're calling data center virtualization. This is more or less single tenant, large scale network virtualization. Right now we're trying to assign each task in the data center its own IP address, and that will eventually get us to task migration, that sort of mobility. In the more canonical sense of NVO3, we also think this could be applied to just generic data center virtualization. There is an address format in ILA which allows a virtual network identifier and virtual address, very similar to kind of the encapsulation formats of NVO3. And one thing I should mention is, so that was multi-tenant virtualization. We also have the concept in the data center to address many more things beyond just tasks. So you can think of anything that you would want to address, individual pieces of content, maybe devices, what have you. Potentially any of those could be individually addressed and could be somehow mobile. So we are contemplating a really large scale uptick at this at some point to the billions of nodes potentially within a single data center. And then that gets us into possibly the other large scale use case of ILA, which would be the mobile use case, particularly the 5G type of mobility. In this case, every every end user device could potentially have its own identifier. And we get mobility by the ILA component. So when the identifier moves from network to network, its locator changes, and that's one way to get mobility at large scale. Next slide. So some of the advantages of ILA, non-encapsulation. So unlike the 3 NVO3 encapsulations, for instance, there's zero overhead on the wire, but we can still implement overlay networks. That also has great implications in terms of all the headaches of encapsulation. So we don't need to worry about MTU, don't need to worry about the UDP checksum, all the normal TCP offloads, what have you, will just work. It's transparent on the wire. Also, unlike, say, the related ILNP, which is also an address split that ILA is based on, there's no requirements to change the transport layer. This is all done at the IP layers, just manipulating the destination address and packets. There is open source implementation, so we have this in Linux. And actually at the hackathon Saturday and Sunday, we worked with the VPP guys, Cisco guys, on an implementation. I think we'll have Pierre in a second give a little bit of an update on that. Next slide. So one major change from, I guess the last time we presented this, we introduced checksum neutral mapping. So this is similar to the NAT64 RFC 6296. The idea is to compensate for the change in the destination address by changing a similar or a part of the packet to offset the checksum change that would be in a transport checksum. So in this way, we can do a checksum neutral mapping. Checksum is still correct on the wire. The transport checksum is. We don't have to parse into the transport layer to adjust the checksum. So it works out pretty well. And it was pretty easy to implement, actually. Next slide. So general status, so we are in the midst of deploying this at Facebook. As I mentioned, we're going for an address per task right now. Several reasons for that. It's not that we immediately need the task migration, but just having an address per task actually solves several things. In particular, if you consider that we have a whole bunch of applications running in the data center, and say 2 instances of the same application run on the same device, the only way around that right now, before something like ILA, is to give them each their own port. And when we assign each their own port, that means we have to have a service lookup that doesn't look up IP address for some name. It has to look up IP address, port, maybe some other information. So when we give an address per task, then the service lookup just becomes, here's the name, here's the address, and the port can be well known. So I can have as many applications as I want on a particular device bind to port 80, and they all have different IP addresses, so there's no collision. We are also developing an ILA router, so it was that component in the flow diagram. Right now I actually have an intern working on this in Express Data Path, which is sort of another high performance data plane we're working on. We have the VPP work at the hackathon. And for the control plane, initially we're going to do this with BGP, but in the long run, we think we need something that scales a lot more. And also, as I mentioned, we're looking at a resolution redirect protocol for ILA host. Next slide, that it? So I think that pretty much describes the status. So we did present yesterday in the 5-gang IP BOF, which is the 5G network as a potential solution for 5G mobility. Had the ILA hackathon event. We're looking possibly at a hyperscale address management initiative. So the idea here is this idea that we have to map billions and billions of addresses to other addresses is actually a common problem of scale. Of large scale, so maybe this is an initiative that we should have as a common issue. The identifier locator, I know that this has some history in IETF, but it does seem to be coming up more and more, especially in the mobile context. So, should that actually have its own direction? With respect to ILA itself, so we are looking for a home right now. We had discussions with both the routing area ADs, inter-area ADs. Actually, we talked with the in-area ADs yesterday. Their idea was that there's actually two components to this. One is the address manipulation itself seems more like it's in an area, but the routing component seems more like it's in routing area. So we'll have to follow up on that. Pierre, do you want to give a update on the hackathon?
So, hello everyone, my name is Pierre Pfister. I'm going to go quickly.
Do you want to talk about this? I can show the slides.
I don't have slides.
You don't have slides.
That's okay. I will send a mail to the mailing list with all the details, trying to clarify what I may say here very quickly. So this is just an update, status of the implementation, the hackathon we made. The hackathon took place on 2 days, Saturday and Sunday. We were a small team, and we made an implementation of this draft from scratch, so 0 lines of code initially, as part of VPP, which obviously was already there. VPP stands for Vector Packet Processor. It's a virtual router, so it's a fairly good use case for VPP, the ILA translation. Overall, the implementation is 700 lines of code. It's fairly small. So as said, we did it from scratch in just 2 days, but let's say 10 hours of work. It was fairly easy. As it comes to interoperability, we also tested with Linux, and we showed that our implementation interacts with Linux fairly well. Tom was in our team, but I actually had to ask him only one question, which is fairly good for a draft that hasn't been so much, it's a fairly recent draft. So that one question was regarding the checksum bit handling, so something quite specific. But overall, my experience is that the draft is fairly well explained. As an implementer and somebody who is not familiar with NVO3, I would have liked some more explanation of what is expected from the user as it comes for configuration and the data model that I'm supposed to use as an implementer. But overall, the message is that it works. I think it's a fairly elegant solution, technology. Maybe some clarification is needed with the different types, because in the beginning it's this 6464, and then at some point there is the VNID and so on. So it's a bit disorientating, but we did it. It worked. And the performances are really good. Like, it's really something simple to implement, and it works. I think it's deployable. I mean, obviously, you know it really better than me, but I think it's something that will work in data centers.
So I would point out it was awarded, what would we say, best overall project in the hackathon. It was my first hackathon. It was a lot of fun, and I really want to thank Pierre and the VPP team. It was really enlightening. I think we made a lot of progress just in a couple of days, which is amazing.
Eric Nordmark, so one comment on the slide. It says 5G and IP BOF. If people are looking for that BOF, well, it wasn't a BOF. It's a side meeting. But
when I made the slides, that was a random idea. Okay. I don't know if Linda's here. So I've been working a little bit with Linda Dunbar on the concept of the HSAM, hyperscale address management. I think the plan was to start a mailing list on this problem. So I don't know about the identifier locator split. In the 5G working group yesterday, I think Dino made some really good motivation that this is the only way that we're going to be able to solve mobility for mobile. So to me, it seems like there's something there.
David from Mellanox, can you elaborate what was the issue with the checksum?
For the process, or?
Yes, that's for the VPP implementation.
So the checksum calculation itself, as Tom said, is not that complicated. So I didn't need his help to understand what was going on with that. It's just a bit that on one side, I mean, the bit is in the format on both SIR and ILA side, but it's not clearly explained that the implementation is supposed to set the bit when it translates from SIR to ILA, and when it translates back from ILA to SIR, the bit is supposed to be reset to 0. So just this little detail.
So one of the interesting things was the model that we had implemented in our lab was different than the model they had implemented. So that's a great thing about interoperability, right? You realize that when other people look at the same problem, they may have a different perspective on it, and both were correct. But that was kind of interesting, and I think there was some ambiguity there. So maybe we need to describe a few of the use cases in a little more detail.
Yeah, you mentioned this, the first bullet, 5G IP BOF, but actually it was BARBOF.
Don't we call those lunch BOFs, or?
It was not an official BOF.
Okay, I'm sorry. I use legal
yeah,
terminology. That's my mistake.
Yeah. I wish you were there. Yeah, I'm with Dirk from Deutsche Telekom. We are chairing this 5G IP activity in IETF. It's a mailing list. Everybody's invited. If you're not on the list, we have more than 200 people. So yeah, Tom presented ILA, some aspects of ILA, not the same, I think, right? But and we had some discussion. Personally, I have some concerns the way you changed the ILA. Yeah. For example, the router is introduced, which is not in the original ILMP. So that is a big issue, I think, and some other things. But anyway, it's not really, I think, something to discuss here. And I'm not sure, identifier locator BOF, what do you mean? There's already LISP working group which works on this.
Okay,
ILMP is already finished. And then we are discussing some use of these things in 5G. What other thing to do in identifier locator BOF? I don't understand that.
Okay, thank you.
Okay. Okay, I think this is Greg. Oh, you, okay.
I think I will hold on to the mic. So I don't remember exactly what we reported back out last time in this group, because we've been going around to different working groups. So, but these are the members of the design team that have been doing this stuff for like 2 IETFs now. Next slide. So there's a fair number of slides in this deck. I'm not going to cover all of them in detail, but the main thing is sort of showing that there's a set of work here, why we're doing it. There's like 4 different drafts that are out there for people to review and comment on. It's still a work in progress, but the first 2, the requirements and the gap analysis, we feel that are so in reasonable shape. There's still some holes in the gap analysis because it's a gap analysis, no. But there's still some pieces there that can actually be filled in, but at least in terms of laying the groundwork for this stuff. So quickly we'll cover some of these things, but the main pitch is actually getting people that are thinking about operational aspects of networks to see, you know, is this something that's useful, or which pieces of this is most useful in practice when you go and deploy and operate overlay networks? Is there something that has higher priority here? How do we make this stuff happen in the IETF? So next slide. So the motivation for this was that there's work that was started, and this started more than 6 months ago, that work in NVO3 as well as SFC and BEER, people are defining new encapsulations, and then some work started to happen saying, okay, how could I do some form of BFD ping trace shot, some OEM with this stuff? And Aliyah, as the AD, said, but wait, are we doing this thing completely decoupled in the different working groups? Can we go and look across the different working groups and across the different encapsulations? And look at the sort of totality of those things. And we've presented a bit sort of status updates in the past. So next slide. So the first one is a requirement document that tries to sort of cover things using the OEM terminology. If this is not familiar to people, you can go, there's pointers to where you go find out about the terminology, but it's basically being able to detect faults both by having ongoing activities to measure things, as well as when there's something wrong, go and do the equivalent of a ping or trace route to find out what is wrong and where it's wrong. Performance monitoring, you're looking at things like counters, as well as injecting packets to measure things, getting alarms. So AIS is I translate into my head to ICMP errors, right? Basically getting something back from the network layer saying something went wrong, and other parts about resilience and security. So that's what the document covers. Next. So the requirements we actually put down are listed on this slide. So there's a large number of things, but it's basically, the key thing is keeping the stuff decoupled from the transport itself and seeing what can actually be reused for the different encapsulations, but covering on-demand things as well as proactive monitoring, unidirectional, bidirectional, fault management, as well as performance management. And PathMT discovery is the thing that matters as well at the end of it. So that's sort of what we try to cover. Next. I don't know if we need to go into these details. The slides are there for background, but I'm more interested in hearing what the room has to say at the end, so I'll go through these fairly quickly. But yeah, we can go to the next one. Oh, one thing that's key here, which it shows up in these networks where people run data center networks, is actually fairly wide ECMP. So being able to manage well networks with large ECMP fan out is definitely something that matters to people. And it actually matters to them even if they're not doing overlay networks, right? Just that's something that showed up more over the recent years. Next one. Some of these things around performance management have been discussed in NVO3 in the past, but the extent at which you can actually measure things by having both explicit probes as well as having some form of bits or timestamps or something in the packets as they fly by. So this is something that we're covering in the document as well. There's some terminology question here, and I don't think it's important to have good and clear terminology, but we don't have to delve down on that. But the last bullet is basically about how do you define passive performance management? And is it only looking at counters, or does it include things when you set a bit in the packet or a timestamp or something? Does that count as passive? You're not injecting new packets, you're just modifying packets as they fly by. People might have different views of that terminology, but this is the terminology we used in this document. Next. So the next document is the gap analysis. Yep. Next one. So the thing that we set out to do is look at, okay, we have tools in the IETF, like various forms of ping, regular IP ping, LSP ping, trace route, BFD. We can use those tools for the underlay, but it doesn't tell us much, or it doesn't tell us anything about the relationship between the underlay and the overlay. So in the overlay, how do you actually know whether some particular VNI is available at the destination? Right? Well, you could run the ping in the overlay itself, but can you actually tell by doing something in the underlay and finding out this mapping up from the underlay to the overlay? And being able to think about that and say, can you reuse the existing tools, where reuse actually has two different facets. One is that it's familiar for the operators if the same type of tools are available, that they're used to from IP networks and or MPLS networks. If those tools are available for these different overlay networks, it's less of a burden for them to learn things. But the other one is, and I think that might actually be the most important thing in the larger scheme of things, right? When we're sitting here in the IETF implementing things, you might say, well, if we can implement this thing once with the same code points and the same code, it's better. But that's a very small part of the overall sort of ecosystem in terms of getting this out there. But there's some benefits in being able to sort of reuse packet formats and code as well. Next. So the document actually looks at, what are the existing OEM protocols and what are the gaps there. And this is looking at NVO3, SFC, as well as beer, right? And then how those existing protocols apply to the different overlay networks that are being discussed. So that we've tried to put some things in there about this is how things look like for NVO3 and SFC, etc. But this is an area where we can get help from this room and other rooms at the IETF to help fill in more of that. Next. So the setup tools, these are probably familiar to people in here, but there's various flavors of BFD that is used today for continuity checks. And there are some aspects, there are some sort of little protocol questions in here as we go and look at the protocols, which is how do you identify the sender and receiver? Typically, when you run BFD, you have IP addresses because it runs over IP. Well, if you're doing this stuff for an overlay, is it running basically between the NVE and the NV, and they both have IP addresses? Is it running on behalf of an overlay network, a particular overlay, in which case the source and destination is really a VNI ID on those things, right? That's one of the things that actually might make sense here, to be explicit about who are actually the parties in the OEM operation. There's other tools that exist, of course, like LSP ping and regular IP ping. People have done some work in extending this stuff in beer, and this is something that we can extend here as well. Something that we haven't discussed in the design team, but one of the authors on this overlay traceroute, layer transcending traceroute draft, has some things about how can you return some of these things about ECMP or other things that is useful, following the same pattern that we have with LSP ping. Next. So there are some existing tools to measure delay and loss. And there's also some things, we didn't have a reference in this slide, but there's an alternate marking method that was discussed at the IETF last time. I'm looking at Greg right now, but if you can remember what the actual reference is, but I think it's in the document, but basically ways of being able to efficiently make sure that you're looking at the same counter snapshot at to end by having a bit or two in the packet, so that you now can see without changing anything else in the packet to be able to see, did I lose anything? Did I send the same number of packets as were received within a given measurement period? Let me see, we put these slides together. Yeah, that's about it. Next. So an example of this that shows you some of the questions that show up. The example is not for NVO3, it's actually for SFC, but it helps to illustrate things. Go ahead. So people that don't know SFC, there's basically, it's this multi-hop thing, and the things that are, so you're transporting a packet through some set of devices, and then it goes to service function that does something like a firewall, and then it comes back down and it goes through some other, transport things, right? Routers, switches, whatever, and then it pops back up again. And in that context, you have to be very clear about what you're measuring, right? Are you actually looking at the whole end-to-end thing within this domain, or are you looking at the transport side of things? There's something that here in NVO3, we don't have that issue as far as I know, right? We typically have packet goes from one NVE to another NVE, and it either is an L2 or an L3 service. So we don't have to worry about sort of popping out to something else and coming back, right? But it's useful. The main point to bring this up is that you have to think about what are you measuring. It's the same thing in NVO3 saying, are you testing whether the NVE is reachable? Are you testing whether the VNI is reachable on the NVE? Are you testing whether the particular MAC address in an L2 service sitting in that VNI behind that NVE is reachable? Which one is it? You have to decide, because otherwise you just sort of, you don't necessarily target what you're doing towards what you're looking for. So next. So in the SFC example, right, you have these two things where you can say, well, I can test things between these things called service function forwarders, the ovals here, and I can do that to see, well, these things have connectivity so packets can be forwarded. In addition, I might want to be able to see, well, is there actually some service function attached to this? So now I know that there's at least someone that a packet would be delivered to, right? Analogous to that VNI is actually configured on that box, right? Or that MAC address exists in that VNI in that box, whatever. Or you can say, I can do this end-to-end, right? Those are two different models. What we looked at here was the hop-by-hop thing. Next. So there's other parts about the control plane when you go look at things even like BFD, so you need to configure this stuff. How does that get set up? Next. The way you carry these things also matter. So in the case of BFD, because we do the BFD with on top of different underlying transports, there are several different ways of carrying it, and that shows up as well when we do this for overlay networks. So you can carry it with IP UDP, and you can potentially add additional information that describe the source and destination of the parties that you really are measuring. Right? Next. So the design team has talked some about in-band telemetry as well, and it's not sort of, it's part of the bigger puzzle. I think that part of the question going forward is how do we scope what part of the work, but this is definitely something that's needed. So next. So what is telemetry? It's being able to inject packets into the network where you can, they could be regular data packets. In some cases, they might be explicit sort of probe packets, but then being able to extract as much information about the network as possible out of that. So gathering lots of data that can be analyzed offline to a large extent. And getting back ECMP next hop information is an example of this. There was another presentation in the routing working group earlier today about sort of being able to have more information, place for more information in the packets themselves. They could either be funneled off to the side, right, to some controller, or they could travel with the packet. So those are two different things that people are exploring. Next. I don't think we need to go into this detail. I think I covered that, but yeah, gonna go to the next one. So I think that if people are interested in spelling out some more of these aspects of telemetry, we're open to people to come and help us fill in the details in the draft. So on this. Next. Did that slide get duplicated? I think so. But yeah, because I remember seeing that slide like 5 slides back now.
Yeah. Okay.
Okay. So one of the things that we sketched upon is having a common OAM header. So this is something that would sit after the NVO3 header. You can go into the next slide and basically provide a place for commonality in terms of just being able to define different things that can be carried. So I can think of this as defining an OEM channel for the actual OEM messages that will get carried. Want to ask now? Or? Huh. Yeah. So I'm not going to go into the details of this header, but if you want to ask about this slide, then go ahead.
No, not about this.
Okay. Next.
That is the last one. Oh, something else, right? Okay.
So the other thing that we've gotten feedback from hardware folks saying that, well, if we want to have the ability to get accurate timestamps out of things, it's good to define those when they're present, that they're in a fixed location, right? Makes it easier for the hardware on both ingress and egress to put timestamp values in there. And there's also some questions about, if we're going to do something like this, do we use NTP or 1588 format for the timestamps? I think there's more hardware support for the latter today because they use those for other purposes. So, but being able to handle different formats. But so the sketch that we have is saying, well, if you have a common header and then you want timestamps, you always put in these timestamps, and then you can do an ingress and egress, as well as the response coming back having 2 timestamps as well. The details could always be tweaked, but this is something that can then be used for different types of OEM messages without having to have the hardware know in detail about each and every one of them. Next one. Yeah, next. So there's a thing that was said, well, if we're going to have something that looks like ping, you end up with something that's similar to what we have with ping today, that it's an example of a message that would actually ride after the common header and the optional timestamps. And you can then build on top of this and reuse the things you already have with ping, both with ICMP, error extensions, whatever they're called, you can build on top of this. Next. Sam, sorry, you have a...
Yeah, chair hat on, I think we are running out of time, but okay. The other couple of clarification questions. Some of the things you're proposing, the whole effort started as an overlay OEM design, yes, right? So, but the things which are actually what you're proposing applies to the non-overlay as well, right? So the scope is just the overlay or non-overlay as well?
Yeah, that's one. It's a very good question, because that's one of the things that isn't entirely clear to us, right? So some of the things, because of overlay, we need to define some new ways of doing OEM, some new messages. Well, if we're doing that, and sure, we end up reusing stuff that already exists, but if we do that, will those OEM channels be used to carry other things that solve other OEM problems, right? And would you be able to use those things as well, saying, well, when there's no overlay encapsulation, could you use the same things that actually get defined, right? So it is subject to scope creep for that reason, right? If you took a very puristic view of what is an overlay here, you might conclude that, well, the only thing that I need to provide in addition to what the underlay can do is being able to find, sort of probe, is that VNI there? Or get something, and maybe get an error back saying, you know, I see VNI unreachable, right? If talking about NVO3 context, saying that, well, those are things that are specific to the fact that we have an overlay protocol that has this additional concept of a VNI that we need to reach as we pop up to the upper layer. Right?
Okay.
But the question is a very good one. So.
One other clarification question. Are you proposing any guideline or architecture in terms of, like, for example, what if the support is not available on a specific entity? So how does this OEM gonna work? Like, do you consider that as a fault versus?
Greg wants to answer, standing next to you, so.
Yeah. Sam, well, thanks for these questions, because one of the things that probably separates what is explicitly in scope of overlay OEM and where they may be applicable is that for overlay OEM, we are benefiting from making OEM as explicit payload type. And that ensures that OEM packets will be in band with the data flows. So some methods, yes, as Eric pointed out, they still can work if packets being delivered out of band. For example, when you're querying some mapping, it may not necessarily be that you are traversing the same overlay network. You can go out of band and get this information for the query, right? But there are certain operations for OEM where it's important, and your requirement we list as that active OEM packets will be in band.
Sure. I think my question is more in terms of, are you going to give some guideline whether...
Yes, in the gap analysis, we have a conclusion section where we try to summarize something that already being mentioned in a DT in cap document. Okay, so for example, that OEM being recognized as a distinct payload type. Another example could be is that what Eric mentioned, the use of alternate marking method to make it usable as a passive OEM to provide a special flag field in encapsulation layer that would not affect, would not be considered for the forwarding of the packets. So thus it would not be changing its value, would not affect the treatment of the packet by the network.
We'll take that.
So we succeeded with the goal, which is to get people to stand up to talk about OEM at the NVO3 meeting. No, just kidding.
Tom Herbert, could you go back one slide, please? So this ping format, this is within the common header?
Yes,
and then
after
the
common
payload,
header.
And the common header had a type?
I don't remember, is the type there as well?
So the type would identify ping.
Yes.
Why do we need a 16-bit version number for ping? That seems
Yeah,
like, that's kind of scary, actually.
There's probably
We're
room
gonna
for
have a lot of
optimizations
versions.
there, yes.
We are very liberal.
Everybody in this room gets their own version. That's awesome.
Carlos Piñataro, Cisco. Just one quick comment. My perspective is that what Greg Mirsky was talking about is really encapsulation specifics of OEM and not necessarily overlay specifics of OEM. And I think that's a very clear distinction. I think that's the point that you're trying to make. Having a way of identifying OEM given a given encapsulation or tunnel or whatever layer you want to call it, that's an encapsulation requirement for OEM. And that's, incremental value. I think the most interesting part of potential work in this area is when you actually start understanding that you have an under and an overlay, and you can do cross-layer correlation. Given this underlay, what tunnels do I have on the overlay, and vice versa. Mm-hmm. And, it's a lot closer to, Eric, what you were talking about, is my VNI alive? Mm-hmm. And where is it going over?
Yep.
Just a gross. So the Barefoot guys or the P4 guys have been working on an in-band network telemetry proposal that has some overlap with this. I'm just wondering if you had a chance to see that.
No, in what form does that exist?
It's not in the IETF. It's mostly through the P4 consortium or forum or whatever.
So do you know if that's accessible?
Yeah.
Okay.
Yeah.
If you can send a pointer to the list, that would be good. So.
Sure.
Yeah. Thank you.
Hi, this is Dino. 2 comments. Earlier in the presentation, you said you wanted to test the other side to see if a VNI was active. If you have to do that, then that means your control plane failed. So let me give you an example. I'm an NVE. I have 1,000 VNIs behind me. The other side, all I have state for right now is 1 VNI. You're asking me to probe 1,000 things over there where I'm going to get negative answers back. If you have a well-specified control plane, you would know that that NV over there doesn't handle it for all these different things. So that's the first comment. So that's a huge scalability problem. Number 2, you made a comment about how can I verify that this MAC can talk to that MAC, because you wanted to do endpoint reachability as well. Well, if you put it in the OIM, you're going to then have a proliferation of probes going across for all the possible MACs in all the possible VNIs. This can't scale. If you multi-home it, you have an n-squared problem.
I agree.
There's a lot of list documentation that says all the problems with probing. Okay, now, you don't need OIM at the encapsulation layer, because if I'm a VTEP and I originate a ping packet and send it to somebody on the other side, it's naturally going to get encapsulated. That's the definition of in-band. So third comment, it's very brief, and then I'll sit down and shut up. We are just doing probes here to reach the other side of the encapsulator. The encapsulator is trying to find out that the decapsulator's up. It takes 4 internet drafts to do that.
Takes what? I didn't hear it.
It takes 4 internet drafts to describe this OEM procedure. I think this is a bug.
Well, we wanted to make sure that we cover, all the aspects, right? But yes, point taken. So, but on the scaling thing.
No, Eric, you can do all these features with a new protocol that runs on top of it. You can use ping and trace route to find MAC-to-MAC reachability all the way through the VTEBs. So you don't have to put it as part of the data plane. This is control plane features. It should stay out of the data plane.
Well, yeah, I wrote a draft on that 2 years ago, so there is one already. But if we try to cover the bases, right, and being able to do it, I agree completely that it doesn't make sense to do proactive OEM, right? BFD, you wouldn't run BFD across your n squared VNIs multiplied by m for MAC addresses, right? That doesn't scale, full stop. Having being able to define the messages so that if you want to send a targeted probe because you're reacting to something being broken, it might be a useful thing to have in your toolbox, because in particular, if you're doing an L2 service, you can't necessarily send a ping packet to that MAC address because you don't know its IP address, right? If all you're running over this stuff is IP, and you know the IP addresses, sure, now you can just do IP OEM in the overlay. Right?
You always know the IP addresses because they're in your cache that you're encapsulating to.
Okay.
So
do you want to take this to the list? Maybe, because we're out of time now. Thanks.
So I think we're more or less done, but the last slide is basically, let's try to get more discussion of this stuff on the list, and we're going to expand the sort of access of things in terms of the design team getting changed or evolved or whatever, being done, whatever. However, we're praising this stuff so that we can actually do this stuff in the working groups, right? And finding a home for it. But please, if you care about operational aspects, look at this stuff and come and contribute.
I don't know, I can't seem to. Oh, yeah, something was going on. I can't even. Yeah, okay. Yeah, apologies for the scale.
I'm going to talk, or trying to talk about a specific implementation aspect of this overlay OEM. So we call that in-band OEM. I know that's contentious, so let's not go back to that particular discussion. There is a bunch of, we put out 4 drafts with a bunch of authors. They're all listed there. I'm Frank. Next slide, please. So that's the first area of contention. Let me give you my understanding of in-band. So what we have in the title. In-band means, for me, it's traveling with the customer traffic in the customer traffic. So there is a piece of information that I insert into the customer traffic, very much like, and I use this kind of comic thing here, like what we do with onboard units in Germany to monitor truck drivers and truck traffic on the road system. That means they get a little unit. So I changed the lorry a little bit in order to have something to understand what the truck driver does at all times, whether he's speeding, whether he's compliant, whatever. I'm not trying to insert additional cars in order to monitor the road, like police cars or even laser guns in order to monitor the traffic. So that's the understanding of in-band. So it's a little bit closer to what the P4 guys have from an in-band, if you look at the in-paper of those guys, than what other people see with in-band definition. We will change the terminology to something like maybe piggyback OEM or in situ OEM or something, and then clearly define that where the whole thing sits between active and passive, what type of hybrid it is probably likely hybrid type 1. Next slide. So there is a bunch of things that are useful for this type of put metadata into the packets in order to help operations. One area is clearly if you want to go and do live monitoring of a network like where you have heavy ECMP in your network, even more so if you have overlay situations where today people provision ping probes across a set of PEs in order to understand whether a certain SLA is in place in an overlay environment. We also know that people start to prioritize probe traffic on the internet in order to serve the SLA, but not necessarily the traffic. I've recently heard stories, especially if you go to SpeedNet or speedtest.com or similar sites, that the round trip time between Asia and the US is about to beat the speed of light. Why? Because there's proxy services implemented on all these things in order to make you believe the traffic goes better than it is. The only way to go and fix that problem is to monitor the customer traffic as opposed to probe traffic. So don't send extra traffic, send it as part of the customer traffic. Same thing goes, another use case, and we'll briefly touch on that, that's something that we call proof of transit, is if you want to make sure that a certain set of traffic makes it across a certain set of network functions, nodes or whatever, we need to check every single packet and that it goes through. Yeah, you can probe traffic today with physical appliances and you can show your management the cabling. If you go to the virtual world, there is no cables to show anymore, and a single vSwitch configuration can screw up the entire system. So we need to make sure that certain packets travel through a certain path for compliance reasons, especially in the banking sector. And Steve Ewell, one of the co-authors of all these drafts, brought that problem to the table around about a year and a half ago, and we were looking for a solution that is computationally cheap to go and solve that problem. Carry on, next slide. So what we are making the case for is add operational data into the live data traffic of the customer. And to serve these use cases, what do we want? We want something like node ID inserted, ingress, egress interfaces inserted so that we can do tracing, very much like what we had a long time back defined, but never ever really did with route recording. Proof of transit, so proof that traffic makes it across a certain set of nodes. Sequence numbering in order to detect loss or, well, reordering, duplications, timestamping in order to, again, understand jitter delay bounds on overlay situations for the live traffic as opposed to probe traffic, and maybe even custom metadata where you put in GPS geolocation information into the packets in order to understand, did the traffic travel across a certain country that I don't want the traffic to have seen or not?
You just have
so
3 more minutes. So could you,
sorry?
You have 3 more minutes, so could you speed
Okay,
up?
that's fine. Just fast forward. Next slide. So we embed metadata into the packet, and you can't see the metadata, but that's the various things that I make the case for. And how we transport is a different question. So we have defined a couple of transport options for NSH, segment routing, VXLAN GPE, IPv6 with extension headers, so you can carry it in multiple ways, but we try to define one common format on how we want to go and carry that. If we have an OEM or overlay OEM format or container identified here, hey, we would be more than happy to use that one. Next slide. I think that's going into the operational detail. That won't translate here anyway. What we're defining, we're slapping that on pretty much like a tunnel header, but within the packet at the ingress into a domain, and we're stripping it at the egress, and in there we are only updating the array. So we're not dynamically extending the packet size. Next slide. Well, if you go through the draft, you'll find that there is data fields identified or data formats identified for things that are per hop, per node scope, hop by hop, things that are only specific to a set of nodes where we do path verification, or things that are only with end-to-end scope with the sequence numbering. Next slide. So that's the tracing option, that's per hop, that's inserting the array, which we update at every single hop in order to insert the information. Next slide. Proof of transit, where we put in metadata in order to securely prove that a path has been verified, and we use Shamir secret sharing for doing that, which is computationally cheap, only 3 additions, 1 multiplication per hop. End-to-end sequence numbering. Next slide. And that's various transport options that we have defined in the transport draft that goes along with the 4-draft package. Next slide. So we do have running code in FIDO VPP. So not only the LSA guys made that earlier on, but well, you can have a look at how it's implemented in a live environment today, and we have a couple of demo videos up there. If you go to the final one, I just want to make 2 notes on proof of transit, so i.e. cryptographically securing that a packet has made it across a certain path. What we do is we take a secret, we split it into as many hops as we have that we want to see verified, And then at every single hop, we pick up a piece of the secret. And at the very end, we can either piece together the original secret or we can't. If we piece the secret together again, we know that we visited all the hops that we wanted. Otherwise, well, something wrong happened. Obviously, we can't, well, we need something that we need to go split. What we're going to go split, if you go to the next slide, we're splitting a polynomial. And the polynomial is the secret. So what we do is we go back to school math. And in school math, we learned that a polynomial of degree n is defined by n+1 points. So if my polynomial is the secret and I have n+1 service functions that I want to go see verified or nodes on the path, what I'm going to go do is I'm taking n+1 points on the polynomial, and that's the share of the secret that I can dedicate to every single node. Now, at the very end, if I pick up all these points, I can use Lagrange interpolation to retrieve the polynomial or not. That's the base idea of Shamir secret sharing. In order to operationalize that and not have a polynomial per packet, you need to do a little bit more smarts. That's what we describe in the proof of transit draft. And that's pretty much it. So it kind of complements the overlay OAM discussion with what we had. I think the data fields that we identified probably nicely fit into what you guys are doing, which is why Carlos thought it's a good idea to go present here. So thanks for your time.
Great.
And Greg is probably going to go bring up the terminology discussion, which is
no.
No.
You already agree. I'm glad. Thank you. Two things. So you say that this method can be used for ECMP. Unfortunately not, because you are constrained to see only paths that you'll be hashed to. So there could be some paths that your traffic would not be hashed to. So effectively, you would not see all available paths. For that, you need active OAM, where you're injecting traffic, and then you can use some discovery and playing to explore all the paths. The second note is that test traffic can be sniffed on and specially treated. To avoid that, it's very simple. You use dynamic port range so that you hide identity. You don't use the well-known ports, but you use the dynamic port ranges to send your test packets. That's very simple.
Both are true. On the ECMP point, if I want to monitor customer traffic on ECMP, I have to monitor the customer traffic and not the probe traffic. That's the entire point of what we're doing. I think that's the distinction. We do things for the customer traffic and trying to understand how the customer traffic is hashed and whether the customer traffic has a problem, as opposed to whether you have one path that is barely used or not used at all, that might have a problem, right? And the same goes for probe traffic, right? There is ways to identify probe traffic, not based on port numbers, because of the fingerprint for the probe traffic might be the same. So that's the thing. If you want to monitor something, monitor what you're sending as opposed to sending extra traffic. That's the case that I'm making. Okay. And I do believe that there is an understanding of other people that they believe that that's useful, which is why we have a couple of people that worked on this. So I think it's complementing existing solutions. It's not there to replace existing solutions.
Sorry, we are running out of time. We
Too
have
bad.
cut the line.
But we can take that to the list. Thank you.
Thank you. Okay, so the final thing we had from the chairs actually was we're going to spend a little bit of time discussing what to do with the data plane drafts, the encapsulation drafts. We've also had a discussion on the list about this. So we have 3 working group documents relating to data plane encapsulation solutions. That's VXLAN, GPE, GU, and Geneve. And now GU is currently undergoing a working group adoption call in the Int-Area working group with a view to moving that draft to that working group. And the motivation for that really was that GU is a fairly generic encapsulation. It's not specific to NVO3 encapsulations. There is another draft, individual draft in NVO3 that talks about how to use GU for data center VPNs. Now, the concern of the chairs, I think, earlier as well, is that we're really not helping the community by progressing all 3 of these documents to draft standard. And that really leaves us with a number of options. We need to decide what to do about this. So we could publish all of them as informational or experimental drafts with an aim to move one of them to a standard or draft standard at a later date when we have a clearer idea of the deployment status. We could pick one now. That seems to have been an extremely difficult thing for the working group to do over the past few years. And there's other intermediate kind of possibilities, like picking one to move as standards track, keeping the others informational. So we'd like to hear some more opinions if anybody has any at the mic at the moment. There?
Oh, yeah, no, I wasn't going to express an opinion, except that it seems that what data plane encapsulation well, let me back up. The working group picked 3 different data plane encapsulations, which have sat there for the last 18 months. Now, maybe getting a working group draft was sufficient for everybody, but if people want to actually progress the working group needs to make a decision on what to do with them. So let me amplify. One of the uses for an informational draft is to say, when the working group can't come to this consensus, then we can have a lovely paragraph at the beginning of informational drafts explaining that this is a design alternative considered by the working group, but there was no consensus, and it's one of the things that was considered. That's what we're talking about. If we went to informational, if we don't have a data plane encapsulation, it's hard to decide what the working group would be doing after that, because we wouldn't have firm ground to stand on for future work. I'd really like to hear your opinions. Matthew and Sam and I obviously talked about approaches. One of the questions when it comes to consensus is, are there strong technical reasons that the working group can't live with a particular decision? We're gonna make a decision as the working group, okay? The decision could be, nope, we can't pick one, they're all informational, thank you for playing. Or we could do something else. The point is to do something that's actually useful for the industry. So please, you're all here. You've been coming for 4 years. I know you have opinions. Please speak up.
This is Dino. I'll throw out something. I think you should close the working group.
That didn't look like a flipping a coin, but okay. Eric Nordmark. So the other thing that's sort of odd in this space for historical reasons is that there's a fair bit of deployment in the real world of VXLAN, but VXLAN is not an IETF standard for historical reasons. It's not even in product of the IETF. It's an individual stream document, right? But at the same time, there's some of us that say, well, we would like, whether it's for OEM or something else, we would like to pick one more bit in that header. Well, can we do that? And where would we do that work? Because there isn't a home for it. But it seems like it would be useful to define have a home to do that. And it's sort of odd if that's outside of the IETF completely, but there's sort of no place to do that. And that's not casting it, that's just an observation. I'm not saying that the 3 proposals that we have here are necessarily technically bad. It's more about what is actually already deployed out there and being used, right?
Sam Aldrin speaking as individual. If we take these 3 drafts to informational, mind that we have to, any work we have to do in the control plane or OEM have to support pretty much all 3 or kind of thing. So there is no NVO3 specific control plane kind of thing. unless you have to support all three kind of things. So that's one of the things, right? So if you have to really make progress on the other front, we really have to do some work. We have to pick one thing which is deployed and available, right? So one of the data plane caps, which is what Eric was mentioning, VXLAN, right? So it's deployed. So, but it's not part of the working group. So what is lacking in that is the OEM aspect and the control plane or the protocol support, right? So the GPE, for example, provides you that support. So if we really have to support the existing thing, then we really have to see what exactly is out there and just go for it. And if there is really reason for other protocols to exist, then they can always bring it to the working group, make a case, and prove it that it meets the standard. That's my take.
Tom Herbert. So I think there's a reason that VXLAN is not on this list. And even though it's deployed, and that's great, the fact is there's really no way to extend it. And that's precisely why VXLAN GPE had to be a separate protocol, because you could not change VXLAN to include a protocol type. So the problem is, if we say we want to have a control plane that covers all these encapsulations, including VXLAN, because of limitations on a protocol like VXLAN, that makes the least common denominator not to have like add flexibility. Like for instance, for the in-band OAM, we can do that in these three protocols because they have sufficient extensibility. If you try to do that in VXLAN, then we'd have to go back to the, we can use 1 or 2 bits to convey a timestamp. So it's a little bit of a conundrum. So yes, you have VXLAN being deployed, but the fact is that deployment is, it can't go any farther. It's not extensible into the future. We couldn't add security, we couldn't add OAM, we can't add these things. So it's a little bit of a conundrum. So on one hand, we have VXLAN being deployed. If you look at this list, there have been several attempts to modify VXLAN, and it turns out VXLAN probably gets more discussion than these three. So either we say VXLAN is good enough, and sounds like we have to punt on some of the functionality that we're counting on for extensibility, or have to say, yes, we need to move beyond VXLAN with one of these three. Now, pertaining to these three, if you really look at them, they're not that different. They all have the same basic elements. You know, if we really wanted to, I believe we could merge them. It's probably not practical at this point, but they're not that different. They're fundamentally the same. They have a protocol field, header lengths, whatever. So, yeah, it's kind of like, you know, we'll probably settle on point one, and there doesn't seem to be another out, but there's always going to be the VXLAN is there, and I don't see that going away either. So this group would have to deal with that. There should be a home for it. I would agree with that.
Thomas Morin, Orange. So many of these solutions are looked at essentially mostly from the perspective of implementation in software. So that's probably one reason why people have been happy enough with doing many things, because it's supposedly easy to do in software. Although there is a cost of doing multiple things in software, but we should remember that it's also implemented in hardware. So if VXLAN indeed is not good enough for the future, we need to give a message to the industry of what would be the next step. So we need to pick one. And saying this is kind of weird. Here, it's so obvious. So at some point it shows that you have to tackle the hard work of possibly fierce debates between people wanting this or people wanting this. Maybe it should have happened earlier, but I think the answer should be obvious. You need to pick one.
Okay, any other comments? Okay, I think maybe one way forward, if we have any draft authors for the encapsulation drafts, if they can see the chairs afterwards. So we do need to move forward with this. Yeah.
If you don't mind, Atlas, I would actually like to get some sense of the room as to how many people think we should just pick one.
Right, okay, thank you. Okay, so consensus of the room. So if you could raise your hand if you think we should pick one. Fair number.
And who thinks it would be a mistake for the industry, for the working group to pick one? Sorry, who would be, no, I didn't say that we can force the industry to pick one. I understand that a number of these are out there and deployed. What I want to know is who thinks that it is not the correct answer for the working group to pick one as far as serving the industry goes. We had a lot of people thinking we should just pick one. Who thinks it's a really bad idea to pick one? Great, so we need to pick one. Obviously, we have to discuss it, sorry. We have to discuss it on the list.
Wait a second, I was confused. When you said pick one, did you mean possible option 1, 2, or 3, or pick one protocol?
Pick one encapsulation.
Oh, okay. So
Sorry, pick one encapsulation, not pick option 1 up here. I'm sorry if that was unclear. Do you want to, I'm sorry.
Do you want to go through the list? Okay,
it's up to you, but I don't want to end the conversation.
It'd be good to get an idea, actually, to be honest. I mean, this is just to get some idea. Yeah, let's have a poll of the room. So, put your hand up if you think that one should be VXLAN GPE. What was the question? The question, well, the first question was, should we pick one? And it seems that the overwhelming consensus is yes, we should pick one. And now the question is, we're going through each one of these in turn and saying, if you think it should be that one. So the first one is VXLAN GPE.
Well, actually, hold on a second, please. Matt, instead of doing it as who thinks it should be X, what I'd like to see instead is who has a significant technical objection to it being each of them.
Okay.
Thank you.
Okay. So we'll rephrase that. Who has a significant technical objection to it being VXLAN GPE? Please raise your hand. Yeah, we're going through the, yeah. You have a technical objection to GPE.
So Eric Nordmark, so I think as we have both hardware and software implementations, right, I think that the extensibility pieces in GPE, I think, are a bit limited. And that's why I think the other two are actually technically better in along this axis. And along the other axis, I think it's a wash, right? But the fact that you can't just say, oh, here's some extra options. Maybe you would want it to be even fancier, saying, here's some options that I think hardware might care about, and this is really only for the endpoint, whatever, that it's easier for the hardware to skip or something. But I think that that's one of the key factors, because we know that particularly on the software side, people want lots of flexibility and experimentation and whatever. Great, right? But we also have places where people want to build these things in hardware, but we still need that extensibility. And GPE, to me, seems to be inferior in that space.
Okay. Sorry.
Yeah, I mean, that's essentially the same gist of the argument that I would have as well. And I think, at least for the types of software that we build, it's just not really feasible to use VXLAN GPE.
Yeah, so in terms of GPE extensibility, GPE, if it's combined with NSH, I think carries as much versatility as any of the other protocols. And GPE can encapsulate NSH.
Andrew Dogano, Nokia. Can I ask, in an interest of all of us here, that people who do have objections actually state technical objections and not like saying, oh, it's less flexible, it's as much of a value as saying it's more flexible? Please give an example, something very specific versus general statement.
Tom Herbert, so I'll make 2 points. One is I can answer that question. Several times I've asked in VXLAN GPE, how do we insert a 64-bit security cookie? Because this is something required in the data center. We have to have security associated with VXLAN. Have never gotten an answer. Also asked in the last Buenos Aires, how do I add a bit to either VXLAN or to VXLAN GPE just to do remote checksum offload, and where do I put that? Did not get an answer. The thing though is more generally, we had an encapsulation design team that went through many of these issues. We talked about extensibility, the checksum, we went through the whole gamut. So what I haven't seen, and you know, now doesn't seem like the time that we're going to start talking about technical objections to these protocols. This has been going on for like a year. These have been in the working group for a long time. Where was the discussion, the technical discussion about these? So I don't see in 5 minutes how we're going to be able to choose one of these based on, you know, all the years of experience that we should have been talking about this.
Oh yeah, so to address your point, look, the reason the IETF does consensus, right, is in part to make sure that if there's technical problems with what we're picking, that they've been heard and understood. Doesn't mean that we solve them all, but we should at least be an informed working group when we make a decision about what the technical objections are. Some of them, it might be the case that we can say, this is something, now we know we need to go and address it. But we need to hear as a group what the technical problems are with accepting each of the possible answers.
Yeah, sure, but shouldn't we have done that on the list? So that's my point. There have been technical issues raised on the list. We had reviews and things like that. So it seems to me that these questions should have been answered.
We will obviously also be taking conversation to the list. I would have hoped that we would have had these conversations on the list, but we didn't, and sometimes the way to have a difficult conversation is to first force it in person.
Lucy, Yang, question. Since we already published this encapsulation draft, so if we're picking one here, what that means the other draft can also be published as a experimental because there's already implementation in the industry.
Yeah, I mean, I don't think we're saying we can't publish something as experimental. What we're saying is that we really feel that we need to pick one as a standards track document to put a stake in the ground and to enable a control plane to have something to deal with as well.
Yeah, so I just others can continue to pursue as.
They can be informational or experimental. They can continue. Yes, of course. We're not.
Okay, so are there any other substantial technical objections for VXLAN GPE? Can we do the same for the other two?
Yes. We have another 20 minutes until the next session starts, but we'd like to try and keep this quicker this time. So the next one is, okay, we know GU is going to the inter-area working group, so we're really talking about how we treat a draft that points to GU as a solution for NVO3. So who has any significant technical objections? Please raise your hand to GU. Okay. Who has any significant technical objections to us adopting GU to take forward as a standards track? Okay.
Yeah, so it's not a secret, and I mentioned it a year ago, and it was face-to-face so we could have an interactive discussion. I believe the protocols don't need to be extensible, and I'll give you an example. The Lisp header is fixed, and we had to add crypto later after it became RFC. So we had to add 2 bits, meaning a semantic meaning to 2 reserved bits. Okay. Now, what we added those 2 bits for was for crypto. So what happens is you're going to have to change the hardware anyways to support the crypto. So supporting the header at the same time is fine. So by saying you have extensibility in GU and Genevieve, now, and it works. The fact that you add any new type TLVs to it is going to require changes to hardware anyways. So you just might as well create a new protocol with a new UDP port number, and then just go ahead and do it. Now, I am being hardware vendor specific here, but that's where the major costs come in. If we want those protocols to be software only, then I could support that.
So I have to strongly disagree with that statement. Certainly, if you're talking about NICs, you can do things like skip over options and continue to use the same hardware that you've used in the past. You can feed options into things like ACL tables to match them. So there's actually a lot of things that you can do with extensible protocols, even hardware. And I guess it's kind of undisputed that for everything else, there's benefit to extensibility as well.
If you want to interoperate with a hardware vendor, they're going to have to change their implementation. So you have a great feature from VMware, and a user turns it on, and it's all negotiated off on a Cisco that's going to decapsulate. What good is that for the customer?
I mean, in terms of negotiation, there's certainly control plane aspects, but
So it's not even defined yet. That's even better.
I'm not really sure how that's relevant. But I mean, yeah, I don't.
So to that end, I mean, regardless, TLVs are always combinatoric. And if you have the possibility of 5 TLVs that can be arranged any way, if they were 5 flags that have to be ordered, that's what? 32 possible combinations. If you have 5 TLVs, that's like over what, 200. It's much harder in hardware. I mean, I'm not convinced there's an easy way in hardware to do TLVs. Considering the low-level nature of these protocols, I'm actually very worried about TLVs and the fact that you can replicate them. You have to deal with things like that. This could turn into denial of service.
Yeah, the other thing is that even skipping over TLVs isn't free. I mean, we've got a lot of pressure to reduce transit time through devices and to reduce the handling time in the NICs, in the controllers, and needing to skip over and needing to hang on to enough data in the area where we process it in order to quickly deal with the frame when it comes in, the packet when it comes in, is difficult when we have to deal with skipping over a potentially large number of bytes. So, having a fixed format and knowing that the information we need is going to be within so many bytes of the header of the frame, that lets us process it quickly, which is what customers are demanding.
Okay, can we maybe, because we're running out of time, we have run out of time, can we move on to Geneve now, please? So who has any significant technical issues with Geneve? Okay, it's 1 or 2. Okay. Any quick last minute comments to justify your concerns with Geneve, or are they the same as GU basically? Yeah. We can have do you want to, yeah.
So I think this has been useful in articulating where the disagreement is. The other aspect that plays in, of course, is the reality of what things have been implemented and deployed and what, where it's heading. I think that, thank you very much for the conversation. I think we need to keep doing this on the list, but I do think we're going to need to make some type of decisions. I hope that the draft authors for VXLAN and GUI now understand some of the objections and can talk to the people who have strong concerns and consider if there's anything that can be done or how to respond.
Okay. So one last thing, blue sheets, where are they? If you have a blue sheet, could you wave it in the air?
Okay.
All right. One last comment.
So one thing I would like to suggest. So we did the encapsulation design, and that came out with a lot of the technical issues that should be considered encapsulation. So what I would actually like to see is a correlation between these protocols and what we put into that design considerations. Because I think in this forum, we're just replicating so many of those discussions. Like I said, we talked about all of those. So I think, maybe an exercise would be for the draft authors to go through line by line and figure out how they stack up with what the design encapsulation or the design considerations team came up with. And all the authors were on that team, so it seems like it should be straightforward.
Couple of quick points. If anyone hasn't signed the blue sheet, please sign your name. And the last one, if any of the authors of the drafts in the room, could you come and meet the chairs, please? Thanks.
That's the encapsulation draft.
Yeah, I'm sorry, NCAPS.
Thank you.